click Windows, click on Reset Perspective, click Yes, and then we need to go to the Modeled Perspective. Click on Open Perspective and select SAP HANA Modeler and click OK. So once you click OK, now we are at the quick launch. In the quick launch, we can see Welcome to Modeler. So these are the different options that we have. And on the right hand side, expand the system, catalog and content, expand content. Expand content. So let us go to the package, ECC July 19. Expand the package, expand subpackage, expand MD, expand all the views. And first let us double click on the AT underscore customer. Let's double click on AT underscore customer. And select data foundation. So here you would see the joins between various master data tables. So let me just quickly save and validate and click on save and activate. And let us quickly data preview this. Click on data preview and click on raw data. So once we click on raw data, so here we would see the output. So here you would see show log. When you click show log and double click on generated SQL, so here you would see the select top 200 where customer name 1. So here you would see sys underscore BIC. Under sys underscore BIC, here you would see the column view. So this is called as column view. So let me copy the column view. Let us copy the column view. Let us click close and close again. Let's go to the schema sys underscore BIC. So let us expand the catalog and let's go to the schema underscore sys underscore BIC. Now once we go to the schema, let me expand the schema. Let us expand column views. So let us do a filter on the column view. Right click on the column view, click filter and copy paste column view. Click on whole word and click OK. So once you double click on the column view, click on create statement. So this is the code that is generated by the system. So let us see where this code is being executed. So now I'll copy the select statement again, click on show log, double click on the generated SQL. Let me copy this, click close and close again. So that is the column view. So this is the code. This is the system generated code. So now let us select system, right click and click on Open SQL Console. Click on Open SQL Console, copy paste the code, right click and click Visualize Plan. Click on Visualize Plan. So once you click on the Visualize Plan, click Yes. So once you click on Visualize Plan, the kind of project is associated with SAP HANA Plan Viz perspective. Do you want to switch to this perspective now? Yes. So it's changing the perspective. So here, let's click execute and execute again. So twice, let us execute. So once you execute twice, once you have executed twice, then on the right hand side, extreme corner, So 1 minute. On the right hand side extreme corner, here you would see something called timeline. So this symbol represents the timeline. So once you click on the timeline, expand the column search, expand the column search again. So here you see join, table access, and result assembly. Let us expand. Let's just expand. Let's expand everything. Let us keep expanding. So once we have expanded over here now, so here you would see the column search. Now please see here. Yesterday we drew a diagram. So first we're going to see attribute view. When you execute, where it executes on the join engine. So let's go to the HANA Studio. Now here you would see, everywhere you would see JE. So JE represents join engine. JE represents the join engine. So once you expand everything, so let us go to the execution now. So if you go to the execution, let's scroll down to the bottom. Let me go to the left hand side. So here you would see table access. So here you see table access. So here you would see table access. So at the table access, you see search on Delta, and the other one you have search on table. So the number of rows that are requesting on search on Delta is 2010 rows. But when you try to retrieve data from table, it is 0. So what I'm trying to explain over here is analytic views, attribute views are basically views. Views only access data at runtime. These views, now the table is T005 view. The name of the table is T005 view. T005 view. Table name is T005 view. T005 view table is under catalog. Views are under content. Views access data from catalog objects from tables in runtime. So let us go back to HANA Studio. Let's go to the schema, HANA user. Let us expand the schema. Let us expand the schema. Let us expand tables. So once you expand the tables, let us go to the table T005 view. Table is not displayed, so let me filter on the table. Let me right click on the tables, filter T005 view, and click OK. So here you would see T005 view table. Let me double click on the table and click on runtime information. And click on runtime information. So once you click on runtime information, now please see. So let me represent this in a paint. Let me try to represent this in paint. So let's go to the paint. Now let me, so this is the table, which is T005 view. So attribute view is accessing this table. Now when attribute view is accessing this table, now the attribute view creates a runtime object, which is a column view. The column view has a logic, and this column view is executing on the JE engine, which is the join engine. So when you execute the column view on a join engine, the attribute view is processed. The attribute view is processed, and the underlying tables. So the underlying tables are processing this data. So if you see T005 view, the table is broken down into two parts. One is known as delta, the other one is known as main. One object is known as delta, the other one object is known as main. Now if you see the pictorial diagram here in the HDB, so here you would see the table access, search on delta and search on main. So table is basically, a column table is basically divided into two parts. One is a main, the other one is delta. So how many records are we requesting from delta? So 2010 rows we are requesting from delta. So we are requesting 2010 rows from delta. So how many from main? From main it is 0. So what are the total number of entries? So what are the total number of entries in a table? So this is, it's only showing you the runtime rows processed. Let me go to the table. The table is T005 view. This table is column store. The table has two parts. One is main storage. The other one is the delta storage. The total memory consumption of this table is 6.5 MB approximately. The number of entries in the table are 46289. The total number of entries are 46289. So these are the total number of entries, the records that we have. So from delta we are only getting 2010 records, and from main we are getting 0 records. But when the select query is fired, when you are firing the select query, it's accessing rows from both these areas, from both delta as well as from main area. So what am I trying to say over here is the total table T005 view is on memory. this total table is sitting on the memory. The table is divided into two parts. One is known as the main storage. The other one is known as the delta storage. Whenever a select query is fired, it is requesting data from both these areas. But from delta, it is only requesting 2010 rows out of 46289 rows. It's requesting 2010 rows. Now only why 2010 rows? Let's go back, click on the graphical view. So here you see the basic predicate SPRAS is equal to English. So when you right click on the table and click on open data preview and click on distinct values, click on SPRAS and click English. So how many rows we have here? 2010 rows. Now why it is filtering on English? When you right click on the system, click properties, click on additional properties. What is the language key? What is the language? English. So now when you go to the attribute view, in the attribute view, the join type is a text join. The join type KUNNR, sorry, regio, KNA1 regio. So what is the join type here? The join type is the text join. So what text join is doing? Because we logged in English, the source is English. So based on this, it is trying to dynamically filter SPRAS to English and only trying to process 2010, where the table, the output of the table where English is equal to 2010 rows. So it is trying to retrieve 2010 rows from delta. It's also trying to retrieve from main, but main it is 0. Now, a table is divided into two parts. One is delta and main. Delta is optimized for inserting of data. So whenever new or updated records come to column table, first it writes the data to delta area. And then the data from delta is moved to main. This process of moving data from delta to main is known as delta merge. A delta merge is a process of moving data. The delta merge is a process of moving data from delta to main, because still the delta merge is not executed. So if you go back to the HANA Studio and if you go back to the table at the catalog area, and if you right click on the table, so what do we see here? Perform delta merge. So how do you know whether a delta merge is performed or not on this table? So we can see the statistics of tables where the delta merge is already been executed. Now if you want to see the status of a particular table, whether the delta merge is executed or not, you can go to the instance, double click on the instance, let's double click on the instance, click on system information, expand. So everyone is okay with my quality of voice, or the quality of voice is not good? Okay, thank you. So we see the system information because some are not able to hear the voice, that's why. So let us expand system folder. So once you expand system folder, here we see merge statistics. When you double click on the merge statistics, so here you can see whether a particular table is merged or not. You can find T005U. You see there is no entry over here, T005U. So this is 5U1. So we're looking for 5U. So there is no merge yet performed. So now let me perform the merge now. Let me go back to the table. Let us go back to the table. Let me right click on the table and perform delta merge. So click on delta merge. So here what does it say? This action merge the committed entries from tables delta storage into its main storage. Are you sure you want to perform delta merge operation for the tables hana user.t005u? Click OK. So once you click OK, now let us refresh. Now you see here the merge T005U, there are new entry here. So we see the merge is done now. And if you basically see the type of merge is hard. How many number of records have been merged? So these are the number of records that have been merged. So what I'm trying to say over here is whenever we perform right click on the table and delta merge, this is known as manual merge. So when you try to do a merge, there are three types of merges. There are three types of merges. The first one, so in the delta merge, there are three types of merges. One is called auto, the second one is called hard, and the third one is called smart. The first one is known as auto. First one is known as auto. The second one is hard, and third one is smart. So what is auto? Now how does system know whether it has to perform auto? So this is based on a threshold value. Now if the incoming data is more than 1 GB, automatically delta merge is executed. And whenever the system resources are free, doing nothing, especially after the business hours. After the business hours, when system is doing nothing, during that time, the delta merge is performed. So for auto, it takes two things into criteria. The first one is more than 1 GB incoming data, and the second one is, so the first one is it takes more than 1 GB of incoming data, and whenever the system resources are free, it basically does the merge. That is auto. Hard. Hard is manual execution of the merge. When you right click on the table, merge, then it is a hard merge. The third one is smart merge. So what is a smart merge? The smart merge is executed on the application layer. The smart merge is executed on the application layer, that is on the BW. So what is a delta merge? Moving of data from delta to main is known as delta merge. Now why should system perform delta merge? So what is the advantage of moving data using delta merge? Let me try to take one example to demonstrate this. Let's take Indian population is more than 130 crore people. Let me try to take a simple example. Indian population is more than 130 crore people. Now you have a column with name, gender. You have a column name with gender. Now each row in a table is indicated whether it's a male or it's female. Now if the citizen is male, it indicates as male. If the citizen is female, it indicates as female. So like that, for every row in a table, if a UID, Aadhaar card ID, for a particular citizen, in order to mention it takes as male or female for each row. So now let's take male. If you take male, how much space does it occupy in memory? So each string, let's take 8 bits. Each string is 8 bits. So male as a word, it occupies around 32 bits. So 32 bits is nothing but 4 bytes. So if the gender or the Indian population is 130 crore people, and in this 130 crore, if 70 crore are males, and another 60 crore are females. So 70 crore times, it has to repeat for each row it's a male. It means that 32 bits into 70 crore times. So that is what the space it occupies on the database. So that is what the space it occupies on the database. So this is usually for a row-oriented table. So this is how it stores data in a row-oriented table. But when we store data in column, so what system does is, so instead of storing actual male, it maintains a lookup table. It maintains a lookup table where it specifies male is equal to 1. When male is equal to 1, it means that 32 bits of space of male is stored in 1 byte, because 1 is an integer. So 1 is an integer, it occupies around 1 bit. So 32 bits you're trying to store in 1 bit. So in this case, so wherever it sees male in the table, so instead of storing the actual string, it will store only the references to the string. So when male is equal to 1, when female is equal to 2. So if wherever it sees male, it will replace with 1. So this technique is known as encoding of data. So you're trying to encode. Encoding is nothing but converting from strings to integers. So what are we trying to do here? We're trying to convert from, this is a string, takes 32 bits. So we're saying string is equal to an integer which is 1. So 32 bits is stored in 1 bit, which is 1. So trying to convert from strings to integers. So this technique is known as encoding. So when is encoding executed? On the delta, it stores as mail. When you move data from delta storage to main storage, it converts as string. So now let me come back and let us see the table. So previously, how much was the size of the table? The total memory consumption of the table was 6.5 MB of data. Now just now I performed delta merge, so after that I haven't refreshed. Let me click refresh now. So once you click refresh to see the new values. So how much was that? 6.5 got reduced to 1.2 MB of data. So why the space got reduced? Because the data is encoded. Now what is encoding? Encoding is nothing but converting data from strings to integers. So when you convert strings to integers, obviously it takes less space on the database. Now please see, previously the main storage was empty. Now in the delta, previously it has larger storage, now it is only 16 KB. So it has only 16 KB of data. The main has 1.2 MB of data. So now when I execute the query again, so let me come back. Now this is delta where the data is accessed. So if you try to refresh this, try to execute the query again. Now please see, what is the data it is trying to access from delta now? It is 0. The number of rows that are now accessed from delta is 0. But how many number of rows it is trying to access from a table? 2010 rows. So the data from delta is moved to main and data is read from the main table. So previously, if you see, the 2010 rows are accessed from delta. Because now delta merge is executed, which is a hard merge, the 2010 rows are now moved on to the main area and deleted from delta. So previously the whole table, the size of the whole table was I think 6.5 MB. Now it is reduced to, see the size of the table now, it is reduced to 1.2 MB. So 6.5 to 1.2 MB. Almost more than a half, it compressed the data. So what is the advantage over here? The advantage over here is, let me try to explain this. Whenever you move data to a table, first it goes to delta. Data is not compressed. The data from delta is moved on to main by using delta merge. The data is compressed over here. When you do a compression, before compression it takes around 6.2. After the compression it takes only 1.2 MB of data. So previously, in order to store this table, you require 6.2 MB of RAM, but now you only require 1.2 MB of RAM. So it means that you require approximately around 6 times less the space that you require. So for example, let's say you have 60 GB of data. 60 GB of data. The same 60 GB of data is now reduced to 10 GB. Now if you're trying to purchase 60 GB of RAM in the market, let's say 10 GB costing around 20,000. So 20,000 into 6 times is the amount of money that you have to invest to store 60 GB of data. Now because you have a compression on the column table, it takes only 10 GB. So the amount of money that you have to invest to store 10 GB of data is only 20,000 INR. So here you require 1,20,000 rupees, but here you only require 20,000 rupees. So that is the major advantage of a column table. The major advantage of a column table when you compare with row, in row, the entire table has to be scanned and there is no compression. But in column, the way it stores data, it compresses data because it doesn't store the actual strings but only stores the references for values. So in a column store, it executes encoding. Encoding is nothing but converting from strings to integers, wherein it takes less space to store data. So now if this is a table, now when user is executing a select query on this, when user is trying to execute a select query, now it reads from both the areas. The reason being, the system is not sure whether the data is over here or whether the data is over here. So when reads or when selects, it selects the entries from both the places. But which is more faster? Reading data from main area is very faster. Now why reading from main is very faster? What is the reason behind it? Now tell me one thing. Is 60 GB of data loaded faster to the CPU? So after the memory you have a CPU to process this data, and then the CPU will process and gives back the result to the user. So will 60 GB of data load faster to the CPU, or 10 GB of data that is compressed will load faster? Obviously the compressed data will load faster. So 6 times fast it will load to the CPU. So that's why main area is optimized, because data is compressed. When data is compressed, it uploads faster to the CPU. So when it uploads faster to the CPU, the same data, now will it again show male is equal to 1 and female is equal to 2? Now, because that is the way the data is stored in main. If again it is showing us 1 and 2, the user may not understand. So user doesn't understand when the data is encoded. If it shows the same encoded data back to the user, it doesn't understand. So system has to decode again. So encoding is done for effective storage, and again when user is trying to view data on the fly, it has to decode. So decoding of data is executed at the CPU level. At the CPU, there is different cache memories like L1 cache, L2 cache, and L3 cache. So you have L1, L2, and L3 cache. So the decoding is executed at the L3 cache memory of the CPU. So where it again converts from integers back to strings on the fly. So when user is trying to access data at that particular point of time, and again the decoding is executed and shows back the same data to the user. Now please see, the table is already compressed. Now this was the previous result. So let me again right click on the table and click data preview. So do we see the same data again? So if you see the land 1 GB, land 1 GB. So how many times the GB has been repeated? Great Britain, 4,234 times GB has been repeated in the table. 4,234 times. But system only stores unique values. But when we try to access the table, it will show as if the data is not compressed because the decompression is executed at the CPU level. Now why only at CPU level? Because now if you see, click on Start Taskbar, and if you try to click on the performance, now you see the total memory consumption is 7 GB and the CPU usage is only 0%. So what is CPU doing most of the time? So CPU is doing nothing but being idle because it's very fast to process data when you try to compare with memory. So CPU is 100,000 times faster than processing data on memory. So most of the time CPU is doing nothing, it's being idle. So when we store data, we store in compressed format. When we retrieve data, the data is decompressed on the fly at the L3 cache memory of the CPU. The major advantage of this entire procedure is two things. The first one is faster read access from column tables, because in column table it doesn't have to read the entire table, it only requires the requested columns required by the user. So in order to scan, so in row it has to scan the entire table, in column only few columns are accessed that are required by the user. That is one advantage. The second advantage over here is the way the column store compress data. Approximately a column store can compress around 10x approximately at an average. At an average it can do 4x, but approximately most of the time you can see 10x the footprint of data, 10x less the footprint of data that actually stored on the row-oriented DBs. So in a way, we can get faster return over investment because hardware is very expensive for HANA because it uses RAM. So when you require less RAM, you require less money to invest in the hardware because HANA is purely an in-memory database. So what I'm trying to concentrate over here in today's session was just trying to show you how the attribute views execute on a join engine, which is JE. When the attribute views are trying to process these entries, so attribute views basically execute, it generates runtime views called column views. These column views execute on JE. JE is optimized for complex joins. So when this view is trying to extract data from these tables, the tables are divided into two parts. One is delta, the other one is main. Whenever we insert data, first data goes to delta. Delta merge is performed. Data moved on to main. When you move main, data is compressed, requires less space to store data. That is the first point. And delta merges are of three types. One is auto, hard, and smart. Auto means system automatically does delta merge. Hard, manually we try to right click on the table, perform delta merge. Smart is triggered by the BW application layer. Now especially when doing delta merge, system converts strings to integers. So it uses several algorithms, and one of the algorithm is known as run length encoding. It encodes data name of the algorithm is run length encoding. If you want to see the table's algorithms, so if you double click on the table, click on columns. So here you see column name. Here you see the total size of the table. And also you can see here each column. For example, let us take land 1. The total size of land 1 is 32 KB. The total size of the column. The main size, it occupies around 31 KB of data, whereas delta only 2 KB. Why only 2 KB is reserved for delta? Now this is for incoming data set. So whatever incoming data, it reserves as 2, but 2 means it's empty. There is no data in it. Now here it also shows the compression ratio. So each column is compressed, and what is the record count, and how many distinct records are there in the column, how many unique distinct records there in the column. So you see loaded means it is on memory or it is on disk. And also if you want to see the compression type, right click on configure table. You can select compression type, select to visible columns, click apply, click OK. And here you can see also the compression type. So there are something like RLE, run length encoding, prefixed, indirect. So all these are different compression types, all different algorithms that SAP uses to compress data and to store it on memory. And finally, whenever we try to access data, the decompression is executed at the CPU level at the L3 cache memory of the CPU. Main advantage, faster reads and effective storage of data on the table. So if you have any questions until here in today's session, please let me know. In tomorrow again, I will continue the session by going to the different engines to process data. So if you have any questions, please list down your questions. I'll try to read down your questions and answer your question. So yesterday's session I will upload today. There's some issue in the uploading. So today you'll get both these videos. So within another one and a half hour, both the videos will be available to you. So merging of tables, one question here. Merging of tables happen automatically or it done manually? It is done automatically, but if required, you can do manually also. But always it is done automatically. The second question, after delta merge, data from delta table is deleted completely. Yes, after the delta merge, the data from delta is deleted completely. Next question, after the compression, can we delete/edit data from the main table? Yes, always you can do that. So whenever you delete entries from the main table, the entries become invalid. So you can delete any data, the entries become invalid. Next, total delta merge is similar like change path or change header. Yes, in order to maintain the changes, HANA follows something called insert only. It means that whenever you're trying to update an entry, the previous entry in the main becomes invalid and only the new value is invalid. So whenever you're trying to update a particular record, the previous record becomes invalid and the current record for the same will become valid. So it follows something called insert only. So next question, 10 GB of data will load faster, but won't uncompression of data will add additional time? It doesn't take additional time because you see most of the time CPU is doing nothing but being idle. So most of the CPU's time, because CPU can execute massively parallel processing. It can scan 3.2 and aggregate 15 to 30 million aggregations. So CPUs most of the time are idle and they process the data massively parallel processing. So in fact, it is very fast. Okay, I'll upload today's videos, both of them. So here we are using the row. You can do compression, but only you're trying to compress repeated columns. But in here, we are doing the compression at the database level. Means the database level, and again, we're trying to store data in column oriented. When you compare row with column, always column has effective compression than row. The same data, for the same data, the columns store effectively than row. For the first time when you upload data, where does the data go? First the data goes to the delta area. Then the data moves on to main area. The SQL generated here has a different syntax, yes, because here it uses SQL script. So smart merge is nothing but the merge that is executed at the BW application layer. Now, for example, let us go to the SAP logon. I'll show you where the smart merge is executed. If we double click on the BW, let's log on to the BW server. Let's continue with the logon. Let's click continue. To go to RSA1 transaction code, let's go to RSA1 transaction code. Let's go to info providers. Let us double click on Delta. So you can just double click on DTP, and here you would find the request to be executed as, let me show you. So here you see trigger database merge. So this trigger database merge is nothing but the smart merge that is executed at the application layer. Auto and hard are executed at the database layer, and smart is on the application layer. Is it mandatory to merge all the tables? So all the merging of these will be taken care by the system. So So delta and main parts are sometimes exist on tables or loaded into memory, or do they exist even on disk level? So even they have exists on disk level because disk is a persistency layer. It keeps backup of all the data. So do we have to schedule these jobs for auto delta merge? No. This is taken care by system by using hot dog merge process. There is a merge process called hot dog which is running on the background. So that process will take care of the merge process. For delta and main are stored in the main memory. On this, on a situation, the data will be moved into disk. While reading data from main, does it decode? Does decode whenever you're trying to read? Obviously, if data is encoded, then it is decoded at the CPU level.